Hello everyone, welcome to this module where we are going to understand about advanced VPC concepts. Okay, so we have done networking part 1, now this is networking part 2 where we are going to understand about advanced VPC concepts such as VPC endpoints and VPC peering. Both of these are really very important concepts when we take into the consideration of connectivity to VPC. And specifically when we talk about private connectivity. Okay, so let us understand first of all what is VPC endpoint. So into VPC endpoint, we are going to understand what is VPC endpoint first of all. Then after we will be understanding two types of VPC endpoint. Basically there are two types, the gateway the gateway endpoint and the interface endpoint. So once we discuss about this and we will be doing some whiteboarding as well. After we discuss about that, we'll be understanding that what is the difference between two. And after that, we would be saying how to perform the demonstration or how to create these endpoints on the console. Right. So let's get started with VPC endpoint first of all. So VPC endpoint is basically, when we want to connect to our services. Now the very first thing comes into our mind is why do we require these endpoints? So whenever we want to connect to any service of AWS, like S3, like DynamoDB, okay? So all of those services basically reside outside our VPC. Correct. So when they are outside the VPC, if our instances wants to connect to these services, then what can we do? We can have our internet gateway over here at the edge of VPC. Our traffic would be traveling to internet gateway. Through the internet gateway and via internet, we would be connecting to the endpoints of S3 and DynamoDB. But what if I do not want to go or, I don't want my traffic to traverse from public internet? I don't want to go through internet gateway, NAT device, VPN connections, or any direct connect connections. So what is the option? To create the endpoint. So it allows you to privately connect your VPC instances to other AWS services. So endpoints are nothing but they are the virtual devices which can be horizontally scalable, redundant and highly available VPC component. So because of this, the single point of failure is not there. Okay, so we won't be failing anywhere over here and VPC endpoints are highly available. Now the two types of endpoints that we would be discussing is gateway endpoint and interface endpoint. Both of these work differently and they do support different types of services. So let us try to understand that what is gateway endpoint. So these are the two types of VPC endpoints. We have to understand that why VPC endpoint. So generally, as I told that whenever we want to access any of the AWS services from VPC, we have to traverse through internet gateway and potentially through the internet, public internet, which can introduce security risk and increase latency as well. With the VPC endpoint, you can establish a private connection between your VPC and the AWS services. So, which allows you to access the services securely and quickly without exposing your traffic to the public internet. Okay, so this would be one benefit. Now, let us understand the two types of endpoints that we have. First of all, we would be discussing about gateway endpoint over here. After we discuss gateway endpoint, I'll be showing you the diagram as well, that how it would actually work. Okay. So gateway endpoint is basically a type of VPC endpoint which allows your VPC to access two services. Okay, only two services are supported over here, S3 and DynamoDB. Because these two services are frequently accessed by our VPC, from our VPC. So it is important that we are not paying anything extra for that because they are frequently accessed. We need a secure connectivity to it. So when we discuss about the difference between interface and gateway, we'll also understand the difference between the pricing options of two. So when you create a gateway endpoint for S3 or DynamoDB, the traffic to those services from your VPC is automatically routed through the endpoint without the need of internet gateway or NAT. Okay. So because it is routed through the endpoint, we have to create the table, route table entry. So we have to specify the route into the VPC route table, and when the traffic is generated for S3 or DynamoDB, it would be using the appropriate route table entry and would be routing the traffic to our S3 or DynamoDB through the private connection. Because gateway endpoints are created inside of your VPC, they are not visible to the internet or any other VPC. Right. So that is our gateway endpoint. Now let me just take you to the whiteboard once and I'll show you how it would actually look like. So here on my whiteboard, right, let us try to understand that how the endpoint would work like. So let's say that we are having one VPC over here. This is our VPC. Okay. Inside of the VPC, what do we have? We have our subnets, right? So let's suppose that this is our public subnet and we do also have one more subnet which would be the private subnet. Correct? Now when we talk about VPC, we generally have internet gateway attached to our VPC. Right? So what is the use of that internet gateway? To traverse our traffic to the internet. Right? So I'll just create one internet gateway over here. Let's suppose this is our internet gateway, that is IGW. I'll change the color of this. Perfect. Now the other thing that we can have over here is, if I don't want to traverse my traffic through the internet, okay, then I can be using gateway endpoints. So let's have this two gateway endpoints over here. And then, okay, I'll just create one gateway endpoint as of now. So what will happen over here is, I told that this is our subnet, right? So let's suppose that this is my public subnet. And this one is my private subnet. So once we have these two subnets and once we have created this entire architecture, now if I have, let's suppose that we have this thing over here, which is representing S3. Okay. Now what else can we have? We can have one or two instances, let's say. So this is our EC2. One in private subnet and one in public subnet. So we have two EC2 instances over here. Right. Now when I want to connect to S3 bucket, then what I have to do? Generally, I'll be traveling or traversing my traffic through the internet gateway, through the internet. Let's suppose one more thing over here, that this is internet. So my instance would be creating the traffic. It would be going to the IGW. From IGW, it would be going to the internet. And from internet, it can connect to the S3 endpoint. Right. So this is one of the way for contacting S3 or for connecting to S3. But what if I don't want to use this? Okay, I want to use something else. So here we would be having our gateway endpoint. Okay, this is our gateway endpoint. What we do here is, in the gateway endpoint, the traffic is routed through the gateway endpoint by the help of route table entries. So now whenever we would be having the route tables for public subnet and the private subnet, if we want to traverse our traffic through the gateway endpoint, then we have to create one entry over there. So for that, what we'll be having? Let's suppose that here we do have one. Just a minute. Okay, let's say that here we have one route table with us, which is associated with public subnet. So into the route table, what do we have? We have destination and we have target. So if our traffic is destined for, let's suppose that this VPC, this is the VPC that we have. So VPC is having the CIDR of 172.16.0.0/16. This is the CIDR. So if the traffic is destined for 172.0.0.0/16, then it is the traffic which should be internally, traversing. So we would say the target is local. But if the traffic is destined for anywhere in the internet, then we would say that go to IGW, that is Internet Gateway. So this route table is associated with our public subnet. Now, the route table associated with our private subnet will not be having the entry for IGW, right? Because we don't allow private subnets to connect to internet. So for that, let's say we have destination over here, we have target over here. Okay. So what will happen? If the traffic is locally traversal, if it is meant for locally traversal, we would make the target as local. Now the endpoint that would be created, the entry that would be created here would be having, when you create the endpoint, okay, when you create gateway endpoint, route table entry would be added over here. It would be having some S3 prefix list, okay, and it would say that the target would be VPC endpoint and S3. So what will happen now? That this is the route table associated with our private subnet, then whenever the traffic is generated by the private instance, then it would be contacting the gateway endpoint. And through the gateway endpoint, it would be connecting to S3. So this is how the VPC endpoints work, especially the gateway endpoint. Okay. The next thing that we have to understand is how the interface endpoint works. So let us also have a look at that. So we know that the gateway endpoint would be only working for S3 and DynamoDB, right? But what if I want to connect to other AWS services like, SNS or SQS, Lambda? So in that case, we have to use the interface endpoints. So when we talk about interface endpoint, this will also allow you to privately connect to your AWS services through your VPC. So unlike gateway endpoints, which is just used for S3 and Dynamo, these endpoints are used with wide variety of AWS services that support private link. So what is private link? We'll be soon discussing about that as well. But when you create interface endpoint in the VPC, AWS creates one elastic network interface where it will create, this will be created in your subnet that will be serving as the endpoint for specified service. So this ENI is assigned with one private IP address. And where this private IP address would be coming from? It would be coming from the CIDR range of your subnet, right? So the private IP address would be used up when you create your interface endpoint. So you have to take care of that. To access the service over the interface endpoint, your VPC route table must include a route to the destination IP range of the service through the interface endpoint ENI. Once this route is in place, your VPC can communicate with the service over private connection, which is being provided to us by interface endpoint. Right. So this is about interface endpoint. We will also see how it looks like, okay, on the diagram and on the whiteboard. But one other question that comes here is, what is private link? Because it says that it will be connecting to the AWS services that support private link. So private link is a networking technology that allows you to access AWS services privately, securely, and without using public IPs. So this is essential for creating a private network connecting between your VPC and other AWS services without requiring your traffic to go to public internet. This will make your connection fast, reliable, and more secure. So private link is supported by many of the services on AWS. It uses a technology called as interface VPC endpoint. So we have already discussed about that, right? So it uses VPC interface endpoints, and both go hand in hand. Right. So that's about interface endpoint. Now let's have a look at the diagram, that how it would look like. Okay. So again over here, what I'll do is I'll be creating one VPC with me. Into the VPC, we would be having our different subnets. So let's say that I'll have two subnets over here again. This is my first subnet. I'll just change the color for better understanding and not getting confused. So let's say we'll just keep this green. Okay. And once this subnet is created, we would be creating a copy of that, and let's move it over. Perfect. Okay, so we have these subnets with us, and what we want in this subnet is we want our EC2 instances. So what is this? Let's call this as private subnet, and this can be our public subnet. Inside of this, we would be having our EC2 instances. Right? Now, what else would be created here? One endpoint would be created, and we said that, we understood that endpoint would be having one private IP attached to it. So let's say this is the endpoint. It resides in the subnet. Okay. And this would be our interface endpoint. Okay. So this interface endpoint would be getting one IP address. Okay. And lastly, let's say that I want to connect to SNS through this interface endpoint. So I'll keep this over here. And now let us try to make this diagram a little bit more detailed. So this is our VPC in the CIDR range 172.16.0.0/0. This is the CIDR range that we have. And for this public, we have 172.16.0.0/24. We are reducing the size of the network. And here it would be 172.16.1.0/24. So this is our another subnet. So when this internet gateway, when this instance would want to connect to let's say SNS over here. So it would be traversing the traffic via interface endpoint. And this interface endpoint would be having one IP address associated to it, which will be taken from this pool. So let's suppose it is 172.16.1.6. So all the traffic protected will be going here to the interface endpoint, and through the interface endpoint, we can connect to the SMS service in the backend. So this is what will happen when we are using the interface endpoint. Okay. So it will be directed to the IP address directly, and it will be working as such. So now that this is clear, let us try to understand the difference between the interface endpoint and the gateway endpoint. If we look at the difference between the gateway and the interface endpoint, okay, let me just put it over here, gateway versus interface. Then you should be understanding that interface endpoint would be consuming your private IP address from the pool. Here, it won't be consuming any private address. Okay, no private IP address would be consumed. Gateway endpoint would be sitting inside of VPC. And interface endpoint would be sitting in subnet. It uses the concept of elastic network interface. Apart from that, if we understand, gateway would be supporting the DynamoDB and S3 service. This will support variety of service which support the public. Right? The next important difference over here is regarding the cost. So gateway endpoint will be charging you. Okay, so here any processing charges or hourly charges are not applied. Okay, but the interface endpoint would be actually charging you. You will be charged based on the usage and the data processing rates for the private link. So charges are applicable in interface endpoint. Okay. So these are the major differences that we can consider while we, understand the difference between the gateway and interface. One more important difference is that we cannot access the gateway endpoints through the on-premises network. So if we want to, connect to gateway endpoint through premise or through VPC peering. What is peering? We would be understanding it very soon. But this cannot be done with the gateway. But it can be allowed it is allowed actually in interface. So you can connect from on-premise and you can also connect from two VPCs which are paired together through the interface endpoint. Okay. So these are the differences between interface endpoint and the gateway endpoint. Now, according to the different use cases, we can select that which one is appropriate for us. The next topic that we would be discussing is about VPC peering. So here in the VPC peer, we would be understanding that what is VPC peering? What are the benefits of VPC peering? And what are the limitations of VPC peering? Okay. So let's take a look at what's VPC peering. So VPC peering is basically connecting two VPCs together when privately, when I again do not want to traverse my internet traffic. Okay. It allows you to connect two VPCs together. So once you have established the VPC peering connection between two VPCs, the instances would be communicating with each other like they are on the same network. So VPC peering can be used for connecting VPCs in the same account or in the different account. You can work with inter-region or intra-region. The connection is private and secure, and it will not require any kind of internet gateway. This can be useful in the scenarios where you want to have sharing, when you want to have resource sharing between VPC or moving data between VPC, or let's say when you want to migrate your workloads from one VPC to another. So let's say we have the intrusion protection and detection in one VPC. Okay, this is my VPC A. Over here, I have intrusion protection and detection. Right, intrusion system. I'll say intrusion system over here. And I have two other VPCs. Okay, this is our, let's say, VPC B and VPC C. So instead of having this system on both the VPCs, I can just have in one VPC, I can have this intrusion system, and whatever data is, whatever data needs to be filtered out can be going to this particular VPC. Or whatever data is coming in to these two VPCs can be going through VPC A to filter out our traffic for intrusion protection and detection. So here I want to share some systems. Okay, I want to share the resources. So in that case, we can be using VPC peering. To set up VPC peering, you need to create the peering connection between two VPCs that you want to connect. This involves specifying the VPC IDs and IP ranges. Now, important point to consider over here is when VPC are paired together, they must not have overlapping IP CIDR blocks. If you have the overlapping IP CIDR blocks, then the route tables would not be able to understand whether to route the traffic locally or to go to the other VPC. Right. So that's why we will not have any overlapping CIDR blocks. Let us see how it would look like. Suppose I have two VPC, VPC A and VPC B. I have these CIDRs. These are not overlapping CIDRs, correct? So into the route table, what will happen? I'll say that if the destination is 10.0.0.0, then go local. But if the destination of the traffic is 172.31.0.0, then we have to go to PCX. What is this PCX? It is nothing but the peering connection that we would have created. So there are two terms over here. One is requester VPC and other is acceptor VPC. These two VPCs can be in different account, in same region or different region. So when I have created a request for peering connection from A to B, then B needs to accept that connection request. There is 7 days limit over here. Within 7 days, this request needs to be accepted or it will be terminated or discarded. Okay, so the same thing happens into the VPC-B route table as well. So if the network that we want to take our traffic to is 10.0.0.0, then go to the peering connection. So now the instances inside of the VPC would be communicating with each other as if they are in the same network. So what are the benefits of this? How this will help us? So the benefit of VPC peering is first of all private and secure connection. So we do not have to traverse through the internet. That is one of the important part over here. So when we are doing the VPC peering, it allows the communication between the instances of two different VPC in a private and a secure manner. This reduces the exposure of your traffic to the public internet, hence making it private and secure. It simplifies the network architecture. VPC peering would be allowing you to connect to your VPCs together as if they were on the same network. So this can reduce the need of complex networking configurations and it makes it easy to manage your network. By VPC peering, you can save your cost. you can avoid the cost of setting up your VPN connections or internet gateways. So this would result in the cost optimization. We can have improved performance because we are reducing the latency associated with accessing resources over public internet. So this can be particularly beneficial for applications that require low latency or high bandwidth. Lastly, we have resource sharing. So it allows you to share resources. This can improve resource utilization and reduce costs by enabling you to share your resources across multiple VPCs. So these are all the benefits about VPC peering. So it seems all green right now, correct? But there are some disadvantages as well for VPC peering. What are those disadvantages? So let us understand about the limitations. Transitive peering limitation. What I mean by that is, let us suppose that I'm having 3 VPCs over here. This is VPC A, B, and C. I have peered VPC A and B together, B and C together. So if I have this kind of connection, it doesn't mean that VPC A and C are connected together. Transitive peering is not applicable here. Okay, so if you want to connect A and C, you have to create a new peering connection between A and C. What is transitiveness? If A is connected to B and B is connected to C, it implies that A is connected to C as well. But this is not applicable in VPC peering. It is one-to-one connection. The other limitation is IP address range limitation. So you cannot be having the overlapping CIDR blocks that we have already discussed. So let's suppose that both of these VPCs have the same CIDR block. Okay. Then into the root tables, what will happen? We would be having two conflicting entries. Here instead of 172, we would be having 10.0.0.0/16. So this would create the conflict, right? We are saying that if the network is this, go to local. If the network is this, go to PCX connection. So root table entries would be conflicting if we have overlapping CIDR blocks. So that's why that is one of the limitation of our VPC peering. The next limitation is creating the VPC mesh. So this is, just like the tongue twister, creating VPC mesh would be a mess. Why do I say that? Because of the transitive peering limitation, this limitation occurs. Let us suppose that we are having 4 VPCs. Okay, and if I want to connect all these 4 VPCs together, then what I have to do for that? I have to pair VPC A with all other 3. So I will be pairing VPC A with C, with B, and with D. Now these would be two-way connections, right? If A and D are connected, then D obviously can talk with A. If I want to connect B, then B is already connected with A, but I have to connect B with C and with D. If I want to connect D, D is already connected with A and B, but with C, I have to create the link. And C is already connected with all. So look at the number of connections, the VPC peering connections that I have to make, and the root table entries as well. And root table entries quota is 100 entries. And into the firms, it is quite possible to have hundreds of VPC. So let us suppose that if I'm having 100 VPCs with me, then what would be the formula, or how many VPC connections would be required, peering connections? So every VPC is getting connected with every other VPC. So it would be N, that is our total number of VPC would be connecting with every other VPC apart from it. So N into N minus 1. Because the connection is duplex, that's why we would be dividing it by 2. So this would be the formula for creating the VPC mesh. So that would go up to, let's say, if I'm having 100 VPC only, okay, then this would go by 99 times 50. 99 times 50 would be giving a very large number. It is 4950. So you have to create 4950 VPC pairing connection. You have to manage those and you have to create such root table entries. So this is a very challenging limitation that we have for VPC pairing. Right. Before we go to the solution of this challenge, we will be going to the portal and understanding that how can we create the VPC endpoints as well as this peering connection. So let's go to the portal and understand it. The demonstration that I'm going to create is a little bit complex. So let us try to understand it, that how we are going to do the demonstration for VPC endpoint. So what we'll be having is, we would be having two instances. One is the public instance and one is the private instance inside of our VPC. With both of these, we would be trying to contact the S3. So because they want to contact S3, they need some IAM permissions for the same. So with both of these instances, we would be attaching one IAM rule. So once we have attached the IAM rule for the instances to access S3, we will SSH into public endpoint, right? To the public instance, not the endpoint, sorry. Then what we'll do is, through this public instance, we would be connecting to the private instance. For doing so, we have to save the key pair of private instance into the public instance. And once that's being stored, how we would be storing that key? Using PuTTY authentication agent and the PuTTY. We would be using PuTTY over here, right? So once our key would be stored into the public and we would be doing our port forwarding, okay, we can connect to the private instance through the public instance. And after that, we would try to connect to the S3 using private instance, but we won't be able to do it because private instance won't be connected to the internet gateway. So that's where we would be creating the S3 gateway endpoint. And after that, when we try to connect to S3 with the private endpoint, with the private instance, we would be able to. So this is the entire demonstration that we are going to have. So first of all, we would be creating two instances over here. So let's get started with that. So I am on my management console. I'm EC2. Over here, right? So what are we going to call this is, we will call this as public instance. Okay, I'll call this public instance. It would be using the Linux AMI. I will keep the size as T2 micro. The key pair would be required over here because we want to connect to this through SSH. So I'll be using the sample one key pair, which is already downloaded with me. Now into the network settings, I'll be editing this a little bit. I want to deploy this in my VPC. And I want it into the public subnet. I want to enable the auto assign of public IP. And for security group, I'll be selecting the existing security, which is for public subnet. Okay, so once this is being done, everything is fine and we would be launching the instance. So instance is getting launched over here. We till then will get another instance. Okay, I launch instance again. And this time we would be creating the private instance, which would be there in the private subnet with private security group and no public IP. Private instance, it is Linux T2. I'll be using the same key pair. Sample 1 would be the key pair. Okay, let's edit the network settings. I'll put this into my VPC. Into the private subnet, I'll keep this. And I don't want IP address for public IP address for that. And the security group would be the private security group. Okay. Rest everything seems fine. I'll be launching this instance as well. So when we create the gateway endpoint, we know that the root table entry would be added. So I'll be taking you to the root table of the public instance as well as the private instance. Okay. So for that, what we can do is I'll be just selecting this public instance from here. Let's go to networking. And if we see in the networking, over here we have a public subnet, right? So let's open this. See that which root table is associated with public subnet. So I am in my public subnet and you can see it is having just two entries, one for the local browser and another one for ITW. Okay, so when we create the interface endpoint, gateway endpoint, a new entry will be added here. Now with the private subnet also, we have this root table. Into this, we have the local browser. So that's correct. We just want that. Okay. Now what I'll do is I'll SSH into my public instance. So for SSHing, what I can do is I'll select this public instance from here. Let me just deselect the instance. Okay. And I'll say connect. I'll do connect from here, or else I will be just going to my CMD and I would be connecting from there. Okay. So here you can see I am into my CMD. I'll go to my downloads page. I'll go to the downloads directory. Now from this downloads directory, what I have to do is I will just try to connect to that EC2. I'll SSH into EC2. So it would be SSH-I and I'll just name the key pair that I have, that is sample1.pen. Then I'll say EC2-user @ and I'll give the public IP address of the EC2 instance over here. So I have given the public IP address over here. Let's try to connect to this particular EC2. So I'll say yes. And we are into the Linux engine that we have created. So here if I try to do AWS S3LS, then this will time me. Okay. Because we haven't attached any role. So it is saying that it is not able to locate the credentials. So we can give the credentials over here using the AWS configure by creating the by using the IAM user, or we can attach a role to this EC2 instance for contacting to S3. So for attaching the role, we can just edit the IAM instance profile of EC2. So I'm here into the EC2 console again. I've selected this public instance. I'll go to actions, into security. I'll say modify IAM. And here I would be applying the IAM role, which I already have created, giving the S3 full access. So I have this S3 role with me, which I've already created, which allows us to access S3 fully. So I'll click on update IAM. So it is successfully attached. Now we'll go back to CMD and try to run the command again. So it would be AWS S3 LS. Now if I try to run the command, you can see that all my buckets are getting listed. Because this is public instance, our traffic is traveling from the internet, contacting S3 and listing out the bucket because we are having the IAM role attached to us. Okay. Now if we try to contact private instance, okay, but before that I'll also attach one role to the private instance, okay. So I have selected the private instance over here. I'll go to Access, Security, Modify IAM role, and I'll apply the S3 role as my instance and will be updating this IAM. So now our private instance is also having the IAM, but how to connect to this private instance, because we do not have public IP address for it, right? We haven't allowed SSH into it. So for connecting to it, we have to use Pagent and PuTTY. So for that, what I'll do is I'll be storing my PPK file. That is, I'll convert the PEM file of my key pair to the PPK format, and I would be storing that into my Pagent. Now, how can you convert this? You can easily download PuTTY from internet. PuTTY generator. Yeah, over here you get the PuTTY, right? So you would be also getting the PuTTY generator. Here it is, see, PuTTY gen, right? So you can go to this app and convert your PEM to PPK easily. But I've already converted it, so I'm not doing it again. So I'll be going to Pagent. So if I open this Pagent app, then it would be going over here. You can see this Pagent app, PuTTY authentication agent. I'll right click on this and I'll say add a key. Now when I'm adding the key, it will take me over here and I'll be adding this sample one key that I have. So I have added that on page to PuTTY app. Into this PuTTY, I'll be going to SSH, I'll be going to authentication, I'll do agent forwarding, and I'll browse for the private key file. Okay. So I have this PPK file with me, and then I'll just click on open. So the one thing was missing, that's why it was not connecting. Okay, we will go to connection and session over here, and I'll give the host name, the public IP address of our EC2 instance, of our public instance. Okay. Now I'll click on open, and when I click on open, I'll say connect once. And here we are being asked that how do you want to connect? So this is the username. Generally for all EC2, we have this EC2 user, EC2-user as the username. So we are connected to the public instance right now, but I want to connect to the private instance through this public instance. So we will do SSH EC2 user. Okay. I'll give the private IP of my instance, of my private instance. So this is the private IP address of my private instance. Now we will say that yes, I want to connect to it. So you see that now we are connected to our private IP, private instance using the public instance. So this is 10.0.0.216. So this was our public instance. This is 10.0.1.96. This is our private instance. Okay. So now that we are connected to private instance, I'll try AWS S3LS. We have role already attached with this private instance, but still it will not connect. It will not connect because we do not have our internet to be, we do not have internet access from the private subnet or the private instances. And we do not have even the NAT gateway attached here. That's why this will time out. It will not connect. So for that, we create the VPC endpoint. So let's go back to the portal and create a VPC endpoint. So for creating the VPC endpoint, we'll go to the VPC console and we'll scroll over here and we have these endpoints, right? So I'll go to this particular endpoint. So we do not have any endpoint as of now. So let's create one endpoint. It is called as S3 endpoint. Let's suppose I want to connect to AWS service. Which AWS service I want to connect to? S3. So I'll just try to filter this out and I want to create the gateway endpoint for S3, not the interface. So I'll select this gateway endpoint. Into which VPC you want to select? So I want to create it into the VPC, my VPC. We have to create the root table entries for the same. So I'll create the root table entries in all of these root tables. Okay, because I don't know that which root table is attached with my instances. So better I'll create entry in all. You can apply the VPC endpoint policy over here if you want. I do not want to do it right now. I'll simply say create endpoint. So once this endpoint is being created, okay, I'll go to EC2 instances again. And into that EC2 instance, if I see the root table of any one of the instance, I'll see that my entry would have been instance. So to the running instances over here. Select my private instance. I'll go to networking and go to the private subnet. Here, if we select this private subnet and we go to the table now, we will see that one entry is being added, right? PL, any number, and will connect to VPC endpoint. Right? So a root table entry is being added over here. And now, if I go back to my connection where I've connected to private instance, you see this buckets being listed over here. It is because we have created the endpoint. So I'll again do AWS S3LS. So the bucket got listed. It did not even wait so much of time, right? Before to that, it was blinking. And why the previous command got successful is because we created the VPC endpoint and it started using that VPC endpoint. That's why after we created the VPC endpoint, these bucket got listed over here. So this is all about our VPC endpoints, right? Now we would see that how to create the VPC peering connection. Okay, so here what we have to do is we'll simply go to the peering connection from the VPC console. I'm into the North Virginia. One VPC peering is already there, but let's create one more. So I'll just say create peering connection. I'll call this as my PC02. What would be the requester VPC? So my VPC is the requester VPC. Where do you want to connect? To this VPC or to other to this account or to another account? So I will just connect to this account. This region or another region. So I'll say this region or say another region. Okay. Now another region that I'm selecting is, let's say, Oregon. So into the Oregon, what is the VPC ID? So for that, I'll go to the here. So we are into the Oregon region now, but for VPC, we have to go to EC console. Right now we are in the EC2 console. So I'll just click on this your VPCs and it will be going to the here. VPC for peering. Okay, so I'll just take the VPC ID of this particular VPC and I'll put it over here. So you can see that we have the, into my North Virginia region, I have VPC CIDR 10.0.0. But into the Oregon region, the VPC CIDR is 172.32. So these are not overlapping CIDRs, okay? We cannot have overlapping CIDRs. So I'll create peering connection over here. So peering connection is successfully created. Now, if I go to my Oregon region and I go to the peering connections, I'll get a request. So you can see pending request. So we have to do the acceptance over here. So you can select that, you go to action and you can accept or reject the request. So once you accept the request, it is provisioning. So it is active now. Okay, we'll go back to the North Virginia region over here and we will just go to peering connections and it is active. My PC2 is active, right? So what we can do is, into the root tables, we can add the entry for that. So into the my VPC, if we go, this is my VPC, okay? And into this my VPC, I go to the subnets. So this is the public subnet and the private subnet. These are both into my VPC. If we go to the root tables over here, you just have one VPC endpoint, right? So what you can do is you can also add one more root to it. I'll just cancel this over here. What I'll do is I'll select this root table from this point and into the roots we can edit the roots. I'll add a root over here which will say that if the traffic is destined for 172 dot, what was the number? This was it, right? 172.31.0.0. No, this one is it. 130. This is the correct one. So I'll see if this is the destination of my traffic, then I want to connect the peering connection, which is my PC2. And you can save the changes here in your root table. The same changes should be done in the Oregon region also. Okay. I do not have any root tables over here. So if you have the root tables, you have to make the necessary changes. You have to add the root for the peering connection and then your EC2 instances would be talking with each other or communicating with each other just like they are in the same network. So this is all about our VPC peering connections and VPC endpoints. So just to summarize, we'll just go to whiteboard once and we'll understand that what we have covered into this entire module. So in this particular module, we understood that if we want to privately connect to other AWS services from our VPC, then we can create something called as VPC endpoints. These endpoints are very useful when you want to securely connect to your AWS services without using internet gateway, any kind of VPN connections or NAT gateways. There are two types of VPC endpoints. One is gateway and another one is interface. So when you talk about the gateway endpoint, then it supports only two services. Those two services are S3 and DynamoDB. This would be creating the entry into the root table, and we can connect to these both. This endpoint would be using the concept of private link, and it will be creating one ENI, which would be using private IP address from the CIDR of our subnet. Interface endpoint reside inside of the subnet, whereas gateway would be residing inside of the VPC. This is free to use and this would be charging us. Right. So these were the two endpoints that we saw. We also saw the demonstration for creating the endpoint. And the next thing that we understood is about VPC peering. So VPC peering also, we can securely connect to VPCs without having any kind of internet gateway or VPN connection between that. So this can work inter-account or intra-account. So you can connect to the VPC which is there in your account or in some other account. It can work inter-region, inter or intra-region. So you can connect to the VPC in your region or in some other region. Right. So here when you create the VPC peering connections, then instances inside of the VPC would be communicating with each other as if they are into the same network. Other thing that we noticed over here is VPC peering connection do not allow overlapping CIDR blocks. So overlapping CIDRs are not allowed on two VPCs. It is also not transitive in nature. So peering connection is not transitive. Apart from that, we understood that if we want to create the mesh, then it will create a mess. So if we have, 10 VPC and we want to connect or we want to peer them all together, then we'll be having n-1 by 2 connections to maintain. That would be 10 times 9 divided by 2. So that would make 45 connections to maintain, and the root table entries are to be also added. So this was the limitation of VPC peering. So these are all the things that we have covered in this particular module. The next module would be talking about overcoming the limitations of VPC peering. So that's all for this module. Thank you everyone.